Hello, in today's lesson we're going to be reviewing probability. There's a lot of GCSE material in here, there's an awful lot in this chapter, but most of it will be familiar. Hopefully this helps reinforce some of your GCSE ideas and make sure that you're happy with probability going forwards. We've got a couple of things to define here at the start. An experiment is any kind of thing that we do. This might be pulling things out of a hat, it might be measuring something. It's anything that you might be able to do. Anything that could possibly be happening is an outcome. So an outcome might be drawing the ace of spades from a pack of cards. An event is a collection of outcomes. So it could actually be drawing the ace of spades, or it could be drawing any spades or any aces. A sample space is all the possible probabilities that you might have, or possible outcomes. So this might be your entire set of cards, deck of cards. If you've got equally likely probabilities, you can simply just add up the number of outcomes and divide it by the total number of outcomes. If these probabilities are not equal, so if it's like a biased dice, then you can't just add up all the outcomes because some of them are more likely than others. In this example we've looked at just to try and illustrate what a couple of these things are. So if we do an experiment, which is to throw a fair coin and roll a fair dice, six-sided dice, that's our experiment. So if the coin lands on heads, the score of the dice is doubled, otherwise the score of the dice remains the same. So here I have a sample space which lists all the possible outcomes for my score. So here we've got score of 2, score of 4, because this is the 1 and double it because we've got a heads, and this is the 1 and don't double it because we've got a tails. So this is our experiment. These are all our possible outcomes, and together this is the sample space. So a sample space is any kind of way of representing all the different probabilities. Quite often at GCSE we put these in a list, but a grid is a far more useful version of a list. What we're going to do here is have a look at some events. Because all of these are equally likely to happen because everything up here is fair, we can just do the number of times we get the thing. So for instance, probability S is 4, there are 2 4s out of a total of 12 events. To get greater than 5, we need to look at this 6, 8, 10, 12 and this 6 here, and that works out to be 5 out of 12. Prime numbers, there are 4 prime numbers in here. We've got 2s, we've got 3, we've got a 5. So it's 4 out of 12, which we can cancel down to a third. So this is just to help you get used to some of the different probability language. So this is an event in here which you'll notice is made up of 2 different outcomes. So it was getting a 1 and a heads or getting a 2 and a tails. This example here, we get given some probabilities in a table. So we're going to have a quick go at this one. So here you'll see this is like grouped data. So a student chosen at random, find the probability that they finish the puzzle in under 9 minutes. So for the under 9 minutes ones, this box here is 7 to 9 and this box is 5 to 7. So for A, our under 9 minutes, this is going to be, there we are, this is going to be 6 plus our 13, all out of the total here, which is 40. So this gives us 19 out of 40 as a total for A. So this is the probability that we get under 6 minutes. For B, we'll look and we'll see this 10.5 here. This is actually not evenly spaced in one of our classes. So we've got our class here which runs from 9 to 11. And we want to know where is 10.5. Using an idea of linear interpolation, or the same idea from histograms, which is just how far through are we, this has a class width of 2, and we want to go 1.5 through. So this is actually like 3/4 of the class and 1/4 of the class above it. So you can use linear interpolation if you'd rather, the thing we use to find the median, but we can split up this class. To be over 10.5 minutes, we're going to include 1/4 of this class, because there's 1/4 of this 12 above 10.5. So it's 1/4 of 12 plus the 5 plus the 4 from this class and this class, all out of the 40, which is our total. So this is for B. So the probability that T is greater than 10.5 is, and this is going to be an estimate because we don't have the actual data. So here we got 3 plus 4 plus 5, so we get 12 out of 40, which we can cancel down to 3 out of 10. These are some basic GCSE probability questions. Have a go at some of these. They should be quite straightforward. To quickly review Venn diagrams, you'll remember from GCSE that we use the words and or to describe different bits of the Venn diagram, and also the word not. So A and B is the bit that's inside circle A and circle B. Sometimes people have seen this notation here, which is the intersection symbol. So this notation here is for intersection. You can use this. This is covered in year 2, but in year 1, if you want, you can just write and. So this notation here means the probability of A and B. The or symbol actually means and as well as or, so this bit in the middle is counted because it's both A and B. So this is, are you in A or B, or the middle bit. And in the second year we use the union symbol, which is a U without a stalk. For part 3, the not A is everything outside of circle A. This is sometimes called the complement and has this dash probability. And you should know from GCSE, because all the probabilities add up to 1, you can do not A by doing 1 minus the probability of A. To have a quick look at this example, I've already drawn my Venn diagram here. In a class of 30 students, 7 are in the choir. So we can't start with this 7 here and put this 7 in the choir box, because the choir circle counts this one and this one together. So we have to start off with our 2 that are in the middle. So 2 are in the choir and the band, so they must be in the middle. These 2 must add up to 7, so that's 5, and these 2 must add up to 5, so this one must be a 3. And out of all these, there are 30 students. These ones here add up to 10, so our outside bit must be 20. So I've drawn my Venn diagram. Find the probability that a student is not in the band. So for this one, we've got, so this is for B, I. We want the probability of B not, so not in the band. So either we can count these up and do 5 plus 20 out of 30, which will give us 5 out of 6. Or you could do probability of B is 5 out of 30, which is 1 out of 6, and then do 1 minus. So that would also work. For II, the student is not in the choir or the band. That's this outside bit here. So this is 20 out of 30. So this is probability. Notice the or in here. So this is actually band not or choir not. So we could use a union symbol for this. This is not in the choir and not in the band. That would be something a bit different. This is 20 out of 30. This is the outside bit, which is 2 out of 3. Here we have a triple Venn diagram. You'll notice we start again with this 7 in the middle, which is cats and fish and dogs, which goes in the middle. We then start on some of the ones that are 2 categories. So cats and fish, we go cats and fish. These 2 here must add to 10 together. So you'll notice we've got 7 in the middle, so this one must be a 3. And we finish the rest of the Venn diagram. They all add up to 100, so after we add up all these numbers, we should get 11 on the outside. So we always start on the inside and work outwards. So we start with this 7, and then we move to these 3, and then we work out to these individual ones, and then we do the outside bit. A client is chosen at random. Find the probability that she owns dogs only. So this is going to be for our A. This is probability dogs only, which is 6 out of 100, which we cancel down to 3 out of 50. For B, this is probability f dashed. So this is all the things which are not fish. So it's this 6, the 8, the 35 and the 11. So this is 6 plus 8 plus 35 plus 11 out of 100. So we could add these things up and we'll get 6 plus 8 plus 35 plus 11. We'll get 60 out of 100, which is 3 out of 5. As a fraction, cancelled down. The last bit is does not own fish, does not own dogs or cats or fish. So that is not anything in this inside of this Venn diagram. So the last one, probability, no cat or fish or dog, is going to be 11 out of 100 because it's just this outside bit that we have here for our Venn diagram. These questions give you some practice on Venn diagrams from GCSE probability. If you want to use the year 2 notation with the intersection and union signs, you're welcome to. If you want to write and or, that's up to you. 2 probability things that you might not have met before is the idea of mutually exclusive and independent. So mutually exclusive are any 2 events where if one of them happens, the other one cannot happen. So if we look at this Venn diagram here, there's no intersection between A and B. There's no bit in the middle. So if A happens, it prevents B from happening. If you're in this circle, you cannot be in B as a circle as well. So this means there's no intersection in the middle, and the intersection bit 0, and you can get the probability of A or B just by adding up A and adding up B. So mutually exclusive events might be things like getting a spade and getting a diamond, because if you draw a card and it's a spade, it can't be a diamond as well. If you've got 2 events that do not affect each other, we call these events independent. So this might be like tossing a coin and rolling a dice. The outcome of the coin doesn't affect the dice at all. It doesn't. If you get a heads, it doesn't make the dice automatically land on a 6. Because these things are independent, we're allowed to get the probability of them both happening by multiplying the 2 things together. So here we have probability of A and B is probability of A times probability of B. And we've done this quite a bit at GCSE when you have 2 things and you multiply the 2 probabilities to work out the probability of this happening and this happening. So you might have heard in probability they say if it's an and thing you multiply them together. This is only true if they don't affect each other. So to have a quick look at 2 very quick examples. Here we have 2 events which are mutually exclusive. So if I were to draw a representation of these things, we'd have a Venn diagram. And these 2 Venn diagrams wouldn't look like that, because mutually exclusive means they don't overlap. So our Venn diagrams, circles, will actually look like this. So we'll have A and B. And these things won't overlap. So we've got a 0.2 in here, and a 0.4 in here. So that must mean the outside must be a 0.4, because together these must add up to 1. And now we can answer some questions. So literally this extra bit of information here just told us what our Venn diagram will look like. So for A, we get given probability of A or B is 0.6, because we can see A here and we can see B here. We don't have to worry about the bit in between because there isn't a bit in between. We get told they're mutually exclusive. B, probability of A but not B. So that's just 0.2. If our Venn diagrams overlapped, then we'd have to discount the area bit in the middle, but we're told that they're not because they're mutually exclusive. And for C, the neither A nor B, neither, not A or B, this is 0.4 because this is our outside bit here. So they gave us an extra pair of words in the question which are mutually exclusive, which means we must realise that we don't have to have any bit in the middle of our Venn diagram. This one here starts off by telling us that two variables are independent. That tells us that our probability of A times probability of B will give us the AND bit. So we can start us off by saying probability A and B is 1/3 times 1/5, which is 1 out of 15. Once we've got this, we can start drawing our Venn diagram. So our Venn diagram, two circles. These ones do overlap because they are independent and not mutually exclusive. And in the middle we have 1 out of 15. Now this A circle has to add up to 1/3. So 1/3 is actually 3/15. It's 5/15. So in here we must have 4 out of 15. For the circle B, we're supposed to be adding up to 1/5. That's 3/15. So here must be another 2/15. Altogether here we have 7/15. So on the outside we must have 8/15. So once we've got our Venn diagram, we can actually work out anything that we're asked to find. In here they just asked to find probability of A and B, but once we've got it, we could draw a Venn diagram, we could answer any other questions they chose to give us. I think I said there are two examples, there's actually a third one here. So here they give us a lot of information about TV series and they give us a Venn diagram already drawn. So find the probability that a student chosen at random watches B or C or both. So all we need to do here is identify which bits of this Venn diagram are relevant. So B or C or both is the 4, the 5, the 10 and the 7. It's basically not this 3 and not this 1. So for A, we have 4 plus 5 plus 10 plus 7, all out of the total, which is 30. So adding these things all up, we should get to 26 out of 30. We can divide top and bottom by 2 to get 13 out of 15. Determine whether or not watching A and B are statistically independent. So here we're going to use the independence as a test. So we can work out probability of A and B from our diagram, which is this 4 out of 30. We can work out the probability of A, which is, it's not 3 out of 30, it's 7 out of 30, because these things are both in A. This is 7 out of 30. And probability of B is, it's 4 and this 5 and this 10, so it's 19 out of 30. Putting these together, if these things are independent, we should know that our 4 out of 30 must equal 7 out of 30 multiplied by 19 out of 30. Now you might be able to tell just by looking at it that these don't work, but we should probably find a way of showing that these things don't work. So I'm going to make both of them out of 900. So for this one, to get to 900, we need to multiply the top by 30, so we get 120. And this one, it will get 900 on the bottom for multiplying those two, so we just need to do 7 times 19, which is 133. So these are not independent. This means that there's probably some relationship. People who liked watching A probably liked watching B, or didn't like watching B. But the probability of watching one does affect the probability of watching the other. We now have a couple of questions from 5C which are about using this idea of independent and mutually exclusive. Make sure you know which one is which. The rule for independent events is in the formula book, so you won't have to remember that for the exam. The last bit of GCSE probability that you need to know about are tree diagrams. So these are really important when you have two events happening, usually one after the other, where one event affects the other event. So this is used for kind of more conditional probability type stuff, but this wouldn't be used for a dice and a spinner so much. But you could, I guess. So here we've got a sampling, and this sampling is actually without replacement. That's why the probability of getting a blue on the first one is 5 out of 12. But there are now only 11 balls, and we remove one of the blue ones, so it's now 4 out of 11 instead. So you can see for each bit of this tree diagram, we've got different probabilities. And these 2 branches add up to 1, these 2 branches add up to 1, these 2 branches add up to 1. So we get 11 on the top here out of 11 if we add them up. So to answer some questions on this, we're asked to do a few things. The first thing we're asked to do is both beads are green. So for A, probability green green gives us 7 out of 12 multiplied by 6 out of 11, which gives us 42 out of 11 times 12, which is 132, which cancels down to 7 out of 22. I'll just put that there a sec. So this one, we looked down our green green column, which is this one, and multiplied the two numbers together. For B, we're after the 2 beads are different colours. So for this one, for different colours, we want probability green blue or blue green. So we're going to work out this one first, which is blue green. So this is going to be 35 over 132 from the 5 times the 7. You might have also noticed, because of symmetry in this 5 and this 7, that this one is also 35 out of 132. So we get 70 out of 132. That's probably going to cancel down, which cancels down to 35 out of 66. So these tree diagram questions, a couple of things to be really clear on is to remember that your probabilities go on the branches. So having a look here, your probabilities go on the branches, and each pair of branches, or a triple of branches if you've got 3, adds up to 1. Our outcomes go on the end, and to get the probability of green green, you multiply together this one and this one. We'd added some probabilities for this one because we had 2 different options. We want this option or this option. A couple of questions here to have a go at for tree diagrams. This should be GCSE recap, but if there's anything that you weren't sure about GCSE, this is a fantastic opportunity to fix all the problems. We will see probability again in year 2, but that's the end of this chapter.